Welcome to our course on the greatest unsolved mysteries of the universe. I'm Brian Schmidt.
And I'm Paul Francis.
We're both astronomers here at the Australian National University's Mount Stromlo Observatory. And Paul here is an expert on quasars. We're going to learn more about quasars. They're some of the brightest, most exciting objects in the sky. But Paul also works on things closer to home, comets, trying to understand how the comets that we see and how they tell us about those that we don't see. And finally, Paul also studies galaxies, huge galaxies, primordial galaxies in the early universe that we still don't really understand very well. So Paul really is an expert in mysteries.
Brian started off his research as a PhD on studying supernovae, which is how stars explode. And then when he came to ANU, he started using these supernovae to measure the expansion of the universe and how it's changing, and came up with a totally unexpected result. The universe was expanding faster and faster and faster, which led to the discovery of dark energy and a Nobel Prize, and Brian losing all his spare time. Since then, he's been working on gamma ray bursts, these mysterious flashes of gamma rays that flood through the solar system on a regular basis, and tracking them down like crazy, continuing his work on supernovae. And he's now also involved in commissioning a new telescope that's going to carry out the first digital survey of the entire southern sky and discover all sorts of interesting stuff.
So Paul, in this course, we're doing things a little differently. Normally when you do a course, you study all that you know about the universe or about the subject. And in this course, we're taking a slightly different tack. We're looking at the things we don't know.
And there are two reasons for that. One is because you hear most press releases about astronomy. It's always, astronomer discovered this, NASA discovers that. And that's because we like to look smart and brag, and we're really saying, please give us more money. But the second, that gives a false impression that we actually know most of the things about the universe, which is very far from the truth. We're actually extremely ignorant. And we're not doing badly, considering we're barely evolved monkeys and some average star on the outskirts of a boring galaxy, but we really don't know very much. The other reason is we want this course to tell you about what it's like to be an actual researcher in the field. And researchers don't research things that are known. By definition, research the things that we don't know.
Yeah, in the words of Einstein, if we knew what we were doing, it wouldn't be called research.
So that's what we're going to focus on. 9 of the greatest unsolved mysteries of the universe, things we don't know the answers about, things that are all active topics of research, and in fact things that we ourselves are researching.
And this course is at a level that's a little beyond the average documentary. It really is going to require some knowledge of maths and physics at science at the high school level.
Yes, so we'd expect you to be reasonably comfortable with doing algebra and basic physics, things like heat, energy, Newton's laws of motion, things like that. If you're not sure about whether you're going to be able to handle the course, have a look at the homework in the first session. If that's looking feasible, then it doesn't get any harder than that, so you should be on track for the entire course. Let me show you how the course works. To start the course, go to the courseware button over here. This is where you'll spend most of your time. And what you'll see is the different sections of the course along here. Each section corresponds to 1 week of study. So you click on the one you want to study. So let's say we've clicked on the first one, it will expand it all out. The main thing you'll see here is the lesson. This is the actual set of videos and questions. So let's click on that and see what we get. You'll see a ribbon across the top. And if you put your mouse over that, it will show you different sections. And what you'll get is videos.
In astronomy, distance is everything. Anything.
You can change how fast you can play it. You can change the resolution, change the volume. Each video is typically 6 or 7 minutes long. And after each, you'll see a question to test your understanding. These questions are not worth any marks. They're purely to test your understanding. Once you've attempted the question once, you can have as many chances as you like to get it right. And also after the first attempt, the Show Answer button will appear over here, and you can click on that to see what the answer is if you're completely stuck. These videos and questions are formed into groups of maybe about an hour of your time. You can split it up or do it all in a 1 hour sitting. Once you've done that for each week, there are a number of other resources. There are reference notes. This is a written summary of the key points from that week's section. This is so that after you've watched the videos, you can come back and just look up the quick facts here rather than go back through all the videos. Then there are worked examples. These are videos showing how to actually solve more mathematical problems based on the stuff we've learnt in that section. So it's one of us working our way through solving all the different parts of the problem, so you can see in great detail how to actually go about using it in mathematical context. These are optional, it's only if you find them useful. Likewise, the practice questions. Here we have a bunch of questions for you to test your understanding of the more mathematical side of the material. Once again, these are not worth marks, and you can try each question as many times as you like, and once you've tried it for the first time, the Show Answer button will show up so you can actually see the official answer. This is a chance to make sure you understand things before finally you get onto the homework assignment. This is the only compulsory part of this, that if you're trying to get a certificate for this, and this will be a set of questions which you can try and solve. These actually are worth marks for the course. This time you only have typically 3 trials, so you have to get right in one of the first 3 times, and the Show Answer button will not appear until the deadline for the assignment has passed. Finally, there's a clue to a mystery. As this course goes on, we'll be building up a strange mystery week by week with a whole bunch of clues, which at the end of the course you'll have to try and solve. But we'll talk more about that later. That's the courseware tab. If you want to see what other people are discussing in the course, introduce yourself, or ask a question, here's where you can post your question. You may have found someone else has already asked the question you want to, in which case you can upvote their post, so like liking it in Facebook. Then there's a progress button here, which is where you can see how you're doing in the course and check that you've which questions you've done and how you're progressing.
So I think that's most of what you need to know to do this course.
If you have any more questions, you'll see there are reference notes here in the introductory section, and also just post something on the discussion forum and we'll answer your questions if there's anything that's unclear.
All right, so let's go on to our first section where we look at the expansion of space.